Hello and welcome back. Today we're going to be talking about solving a system of linear equations. Having covered the basics of vectors, linear combinations, and the dot product, which is material scattered in sections 4 and 5, we're now going to the very beginning of the textbook, which is sections 1.1 and 1.2. We're going to be talking about how to solve a system of linear equations. And a lot of this is going to be review. But first, what's a linear equation? Well, it's an equation of the following form. a1x1 plus a2x2 plus some number of summands is equal to a number b. Here, the x's are the variables and the a's and the b are numbers. So for a quick example, something like y equals 3x minus 2, a line, that's a linear equation. Or something like 4x1 minus pi x2 plus the square root of 7 x3 is equal to 0. These would be examples of linear equations. Notice that we are not taking our variables and squaring them or cubing them or doing anything else to them. So if you take y equals x squared plus 1, a quadratic, this is not linear. The exponential function is not linear. Equations of circles are not linear. So these are all not linear equations. So we're only going to be thinking about the linear type. So let's take these examples, maybe make them a bit smaller, and consider the following kind of warm-up problem. So what we'd like to do is solve the specific system of equations given by two lines, 2x minus y equals 1, and minus x plus 2y equals 0. So these are both equations of a line. I can write them in the form y equals mx plus b by writing y is equal to, let's see, 2x minus 1, and y is equal to 1/2 x. And I actually have these two lines plotted over here in a rough sketch. So these lines are not parallel, and they intersect in the green point. And we'd like to find that green point. As it turns out, it's going to be 1/3, 2/3, but we'll arrive at that solution shortly. Okay, when we say we want to solve a system of equations, this means we want to find a single point, x comma y, which solves both of them simultaneously. One solution. X, y, which solves both. And of course, the green point has that property. The green point lies on the red line, so it solves that equation. The green point also lies on the blue line, which is 2x minus 1, and it solves that equation as well. And since it lies on both, it's on in their intersection, and it solves both simultaneously. So just by using some basic algebra, we can solve it in this case. So here's how you would solve it quickly without doing anything fancy. Take the first equation, 2x minus y equals 1. Take the second equation and multiply the whole thing through by 2. That won't change the equation of the line. But after you multiply the second equation through by 2, you end up with the system 2x minus y equals 1, and then minus 2x plus 4y equals 0 for the second equation, after which you can add them together and the x's will disappear. This will give you 0 plus 3y equals 1. And from here, we can see that y should be equal to 1/3. Then we can get our x value. X is equal to 2y if we use one of these equations. And that gives us that x is equal to 2/3. Ooh, there's a slight error here. This should not be 1/3, 2/3, but rather 2/3, 1/3. And this gives us our solution of xy equal to 2/3, 1/3. Okay, so this demonstrates how you can find, without anything fancy, the unique solution where the lines intersect.